Okay, welcome back to part two for solving and reasoning with complex numbers, the Algebra 2 Semester 8 class for Unit 2. So we're picking up where we left off, now starting on slide 19. So it says let's solve a quadratic equation using the quadratic formula. So right now we saw these different ways to solve for these quadratics, and here we're just gonna get a little bit of a refresher and then apply those ideas that we kind of learned from the part one, where we might have when we're solving for these roots or again solutions to these problems, right? We might have two real solutions. We might have only one real solution, which is considered repeated, and the other one is too complex. And the complex leads us into that idea that we can go ahead and take the square root of a negative number. So as just a practice to go ahead and get used to it, right? Because again, math is not all about just picking up or and solving. We have to practice those concepts in order to get better at them. So the first thing we're gonna go ahead and do, and we're kind of following the same steps here, but let's go ahead and take a look. So we're starting out with the equation 3x squared minus 13x minus 30. Now, two key important things is that one, we like that this quadratic is equal to 0, and it's already in standard form. So this gives me a kind of an easy thing to write out, because it's telling us specifically solve with the quadratic equation. In order to use a quadratic equation, we need to identify A, B, and C. So how do I write those out? I'm going to write out the general formula for it. Ax squared plus bx plus c is equal to 0. And do you see how my A, B, and C line up? So if I were to box them like this is my A, this is my B. Do you see I'm not including the actual variable, and then this is my C. Oops. So I identified my A, B, and C, or you can take a look at the right-hand side. They wrote it a lot more nicer. A is equal to 3, B is equal to negative 13, and C is equal to negative 30. So again, that minus in front of the number will be taken as a negative. Now we're going to apply it to our quadratic formula. Now, our quadratic formula is given to us over here. Again, make sure you have that already in your notes. If you've done a part of, I think it's, yeah, it's within unit 2. I'm trying to remember exactly where we saw the quadratic formula, but we've seen it a little bit already before. So we're just going to set it up. We're going to go x equals, now, for me, I like to write out the parentheses just like this, and then we'll go ahead and fill it in. So x equals negative b plus or minus square root. We have b squared minus 4 times a and times c, and then it is all over 2a. So now what we're going to go ahead and do is follow along. So the first letter that we should enter here is our B. Our B is related to negative 13, so we'll be plugging in negative 13. B again, so again, negative 13. Negative 4 times A, which is 3. C, which is negative 30, all over 2A, or just our 3. So remember, I'm going to go ahead and kind of break them into little portions. We're going to take care of this first, then this right there, and then this. The idea is that it looks very overwhelming, but in fact, it's just breaking them into pieces and then solving them, right? So right here, we have x equals negative times negative 13 is a positive 13, plus or minus. Now let's go ahead and draw our square root, but continue solving. So negative 13 squared is 169. And then we have negative 4 times 3, which is negative 12. Negative 12 times negative 30 is positive 360. So again, I just multiplied those four values. -4 times 3, -12. -12 times -30, positive 360, all over 2 times 3, which is 6. Then again, we continue condensing it down as much as we can, but again, piece by piece. That 13, I can't really do anything to it, so I'm just gonna leave that there. So I have 13 plus or minus. Now inside the square root, I can go ahead and add those two values. We're gonna get 529 for that. And then we're gonna keep that over 6. Now the square root of 529 is a perfect square root, or we can always double check on our calculator, which for a moment, it's actually being blocked. Okay, let me remove that. So if I bring out my scientific calculator using Desmos, again, you can type into Google Desmos scientific calculator, and should be the first link there. You enter your square root button, and let me remind my number, 529. So I put 529. Oh, that's wrong, right? That's be inside. So it'd be 529, and it is 23. So now going back over here, we know that the square root of 529 is 23. So we'll do 13 plus or minus 23 over 6. Now, please keep in mind, if we type in a square root number to double check, especially if we have a large number like this, if we get a decimal, try to see if you can simplify the radical. I do not want a decimal there. I want to simplify the radical as much as I can. If the radical is unable to be simplified, you would just leave it as the square root of whatever that number is. Again, you don't want to write those decimals in there. Unless it's asking for like an estimate, then go ahead. But in most cases, we want it's either going to be a perfect square root where we get a number like 23 here, or it's going to be a simplified radical. Now, remember, here we have two options, or not two options. We have to do two different, solve it two different ways because of that plus or minus. So the first one is going to be 13 plus 23 over 6. And then you're going to have 13 minus 23 over 6. So it's the same setup, it's just with a different sign. So 13 plus 23, we get that is 36 over 6, which can still be simplified to 6, right? 36 divided by 6 is 6. 13 minus 23 is negative 10 over 6, which can still be simplified by dividing top and bottom by 2 to get negative 5 over 3. So that the fact that we got two solutions tells me that if we were to take this this polynomial, right, and enter it into the graphing calculator, we're going to see that it actually touches the x-axis 2 times. And again, you can go ahead and do the same thing. Desmos does have a graphing calculator, so I'm going to go ahead and take a moment and write it in there. All you got to do is go into Google, type in Desmos, D-E-S-M-O-S, graphing calculator, and again, should be the first link. You'll be taken to a page like this, and then on the left-hand side, you're going to just go ahead and type it in. Now, if you're I tend to use the keyboard a lot. You can press at the bottom left corner, show keypad, and it can you can just press on the buttons there. So like I think we started out with, it's 3x squared minus 13x. So let me go back over here. Okay, so 3, here's my x. Now I want to make sure that x is squared, so I'm going to click on this a squared, 3x squared minus 13x again. And what do we have? Minus 30. Oops. Again, clicking on the wrong tab. Minus 30. Now, did you see? I didn't have to include the equal to 0. That's the equation is more than enough. Again, you would probably want to swap out the equal to 0 for equal to y, but here's your x-axis. So if you can see, there's your parabola. You can zoom in, zoom out, and you're gonna notice here, if I click on it, it's gonna show me a little gray dot right there. If you click on it to make it darker, you have 6-0, meaning that answer that we got as 6, and oops, negative 1.667 is the decimal version for our final answer of negative 5/3. So again, these graphing calculators are helpful as well to double check on those answers. But again, they're gonna require you and ask you, solve it using the quadratic formula. Let's go ahead and move into slide 20. So we've seen, we probably have already seen, and if we haven't, we'll bring it up again, the discriminant value. So the discriminant does not, so to be careful with this, discriminant tells us how many answers we have. And remember, we can have either one solution, two real solutions, or two complex. Or in this case, technically, before we used to say no solution, but remember, no solution gets swapped in for complex, for two complex. So the discriminant, and you can see on the right-hand side, we have our quadratic formula, but this red box here, and again, I would like for you to make sure you have this in your notes, right? Because it's going to be a big difference when they say, what are the solutions, right? Meaning you have to use the whole quadratic formula, or versus how many solutions. So remember, this one tells me how many I have, does not tell me what are my solutions. So you'll go ahead and just say like the discriminant. Actually, I'm going to go ahead. Yeah. Discriminant. Oh, can't write today. Let me just write it up here. Okay. And the discriminant does come from our quadratic formula. So sometimes they introduce the discriminant as b squared minus 4ac. And again, that looks very familiar. Why? Because that comes from our quadratic formula. More specifically, it's inside that square root. Because it's inside our square root, that idea is that whatever value we get here before imaginary world, right? We have a negative, meant no solution. We stopped right there. Now we had a 0, that whole square root gets canceled. You're just left with negative b over 2a, meaning one solution. But if you had a positive, then you would have to take the square root, and then you have that plus or minus, which gives you those two answers. So it all wraps up under 1. So this is how I like to take my notes for this one. When I take my discriminant, and you're going to go ahead and identify your A, B, C values from each quadratic. If it's equal to I'm going to put a plus sign here, meaning a positive number, you're going to have two real, let's just say roots, because I think, oh, they're saying solutions, so I'll stick with solutions. So two real solutions. Let's see if I can make it there. Okay. Now, if it's equal to a negative number, so it doesn't matter what number it is, as long as it's negative, right? Or the first one, it doesn't matter what number it is, as long as it's considered positive, it's going to be two real solutions. If it's negative, it's going to be two, like I said, I can't spell today, two complex solutions. And I squeeze it in there as much as I can. Then you have a third one, meaning that it can equal to a positive, it can equal to a negative, or it can equal to a 0. And that means only one real repeated. I think, let me see if they use repeated in here. If it's equal to 0, it's exactly one real repeated solution. So one real repeated repeated solution. So I just had to abbreviate there. So again, you can go ahead and take your notes right there at the bottom left corner, which they have it in sentences. I kind of just like it when it's more condensed. But again, we're going to be using this formula, b squared minus 4ac. So the first thing we need to do is identify a, b, and c. Then plug it into that formula of b squared minus 4ac, and then see what our final result is. Is it a positive number, a negative number, or zero? And then if we follow along this piece right here, if you're with a negative number, okay, you have two complex solutions. Yeah, see, I'm gonna make another note here. It's two, there, not only is it too complex, you're gonna say no real solution. Again, this is for negative. No real solution, but too complex. So again, they might swap back and forth, but the idea is that we're gonna go shifting into those two complex solutions. So let's go ahead and take a look at slide 21, which is a question here. So it says, consider the quadratic equation 2x squared plus 3x plus 5 is equal to 0. So one thing I already noticed, it's equal to 0 and it's already in standard form. We love it. Now we need to identify a, b, and c. So because it already has those two things, equal to 0 and in standard form, as I write this out, ax squared plus b of x plus c is equal to 0. We can see what our a, b, and c are. So let's plug it into this here. So it says the discriminant of this quadratic equation is blank. So is it equal to 0, greater than 0, meaning positive, or less than 0, meaning negative, right? 0 is that neutral number. So again, positive, it would be greater than 0. Negative, it would be less than 0. So we plug it in. It is b squared minus 4 times a times c. So our b is 3, so we're going to enter 3 minus 4a, a is 2, and our c is 5. So we simplify. 3 squared is 9. Negative 4, right, minus 4 times 2 is negative 8. Negative 8 times 5 is negative 40. And then if we do 9 minus 40, that is negative 31. So negative 31 is considered to be equal to 0, greater than 0, or less than 0. And this means that the quadratic equation will have, so because it's negative, right, a negative number, remember it is no real solution and two distinct complex. So again, go ahead and take a moment, make sure you enter for that first one. So again, when you have that negative, it's no real solutions and two distinct. So remember, you can't have a real solution and a complex solution. It has to be either you're going to have a real solution or you're going to have a complex solution. Moving on to slide 22. So again, everything that I had on screen, you should have already taken it down into your notes, because again, that make sure you put a keynote that it says, this tells me how many solutions or type of solutions I have. Does not tell me what they are. So again, now we'll be looking at solving quadratic equations with complex solutions. So some cases we'll be taking the square root, we might be factoring, or we might be applying the quadratic formula. So all those methods that we saw previously in other tutorials, we're going to apply them here. But again, that idea that we can take the square root of a negative number, now we can. So that's what we're going to go ahead and do on slide 23 by taking a look at a couple examples here. So this one we already saw. If you have two terms and there's a plus sign, you are now going to be able to apply the a squared plus b squared equals a plus bi, a minus bi. So again, You just need to make sure you identify your A and B, taking the square roots of each one. So that's one for factoring. Taking the square root. So now they're actually telling us the same problem. They're actually giving us the same problem. Actually, is it the same one? Let's see. Yeah, it's the same one, but it's solved in different ways. So this is so we've seen this example before, and we even did it using the factoring method. X squared plus 25 is equal to 0, where we figured out that it is x plus 5i, x minus 5i equal to 0. So we can take, by factoring, we have these sets of parentheses. You go ahead and separate them. So x plus 5i is equal to 0. X minus 5i is equal to 0. Then you would try to isolate your x. So right here, for this first one, you would subtract 5i on both sides to get x, this cancels, equal to negative 5i. Here you, to isolate the x, you want to add 5i. So you always want to do the opposite sign of what's happening there. Plus 5i here, x is left alone. This cancels. 0 plus 5i is 5i. So those two are our answers there. Now, can I come up with the same answer using the square root method? Yes, I can. For this answer, or for this one specifically, I'm going to go ahead again, do it over here, kind of like almost like a side-by-side comparison. Different steps in solving, or a different method to solve, but you still get the same answer. So we have x squared plus 25 is equal to 0. Now, again, I want to isolate my x squared. I'm trying to get x alone. So the first thing I want to do is to isolate my x squared by getting rid of this 25. So I'll do the opposite of plus 25, which is minus 25 on both sides, and write down as what we see. So nothing happened to x squared, so that is left alone. This cancels. We have equal to 0 minus 25 is negative 25. Now we have x squared alone. I don't want x squared, I just want x. So I'm going to take the square root of both sides. By taking the square root and the square cancel, we're left with x. Now, here it's equal to the square root of negative 25. Remember, here would be like, oh, no solution anymore. But with that negative, I know the negative becomes an I. And we know that the square root of 25 is 5. Now, because we took the square root, remember that's a positive and a negative that we get. Very similar to over here. So again, square roots, you'll most likely take your positive and negative of each of those answers there. Moving on to slide 25. So let's use the quadratic formula to solve for this equation. So remember two things for us to, in order to even start the quadratic equation, we need to have our equation set equal to 0, which I don't see that it's equal to 0 anywhere. And we wanted to have it in standard form. We like it in standard form because that's just easy to find our A, B, and C. So in this case here, I have x squared plus 10 equals 4x. I like that my x squared is already positive. I prefer not to move that one. Plus, if you think about it, the left side versus the right side, you have to make one side equal to 0. You move the 4x over. You only have to move one thing. If you move x squared, then you have to move the 10. That's just adding more work onto your plate. So let's go ahead, whichever one has the least amount of terms, just go with that, moving that one. So currently I have a positive 4x. What I'm going to do right here is that I'm going to subtract 4x on both sides. Now keep in mind, 4x cannot be combined with x squared or 10. So this is going to be x squared minus 4x plus 10. Keep in mind, I already put it in standard form. We keep our highest degree power of a variable, which is that x squared, and then it starts to decrease. And 4x minus 4x cancel each other out. That is equal to 0. So now I have it equal to 0. I have it in standard form. We can go ahead and find our ABC by the quadratic formula, or to plug it into our quadratic formula. This is supposed to be my A, here's my B, and here's my C. Now, I don't have a number sitting there for A. Remember, there's no number there. It's an invisible 1. So now we plug it into the formula, which is x equals negative b. So if you already have the quadratic formula already filled out, go ahead and take a moment to pause the video and fill it out before I do, and see if it matches, kind of like a form to test, self-check to see if you actually know how to go ahead and plug in these values, or if you mess up on one error, again, just be careful. It's good to kind of do this before I end up going over this as well, because again, it's just a form to self-check. Like, okay, I do understand this material. I don't need that. You're not gonna have to worry about it. So, so again, don't forget to pause the video and go ahead and try to work on it on your own. I'm gonna go ahead and get started by plugging it in. So the first letter we had here was B. Our B is -4. So we're plugging that in, -4 again. Then it's minus 4a, which is 1, c, which is 10, all over 2a, which is 1. So now we're going to, again, we do this piece by piece. We solve this here, we take this, then we do this piece, and then that. So again, as like I said, the quadratic formula can look a little bit overwhelming, but it's not overwhelming if you do it portion by portion, or piece by piece. Again, sometimes, like I said, some of these formulas can look like a little bit of an eyesore, but if you simplify this as much as you can by breaking it into parts, you're not going to have any trouble here. So with negative times a -4, you end up having +4. Continue with the plus or minus symbol. We still have our quadratic. -4 squared is +16. Now we're going to multiply all those three numbers. -4 times 1 is -4. -4 times 10 is -40. Oops. My 4 came out a little different there. Oops, there we go. All over 2 times 1, 2. Okay, we're still not done, right? Again, you can't do anything to that 4, so I'm going to leave it there, plus or minus. Now 16 minus 40 should actually give us -24, 30, yep, 24. And then this is all over 2. So I like that we have the square root of -24 there, because like I said, when we have radicals, unfortunately 24 is not a perfect square. So what do we do in this case? We need to simplify the radical as much as we can. So what other perfect square root do I know that can break down the 24? Or if you're not too comfortable with that, you can use that the tree diagram, which I'll do both right now for you. So I know that this, I'm gonna first break it up, and then I'm gonna do the tree diagram so you can at least have both ways to kind of figure things out. So here we have 4 plus or minus the square root of -4 and times the square root of 6. Why did I split them? If I were to multiply them, I get back the -24. -4 times 6 under the square roots will be -24 square root over 2. Now, again, I'm going to show you how I simplify that. we know that this is going to be, now remember before we couldn't take this as a solution, but now we can. This becomes 2i. So this is 4 plus or minus 2i radical 6. And then what I'm going to do is, because it's under the 2, I'm going to break it up into 2 pieces right here and split the fraction just to help us out, to make it a little bit more cleaner. 4 divided by 2 is 2. We keep our plus or minus symbol. The 2's cancel, and we're left with I square root 6. So that is our final answer. We like the setup there. We're done. Let me take a moment to go ahead and do the tree diagram if you're uncomfortable splitting that negative 24. So I'll do it right here. Negative 24 under the square root can be rewritten as, we can say, negative 2 and 12. I'm going to stop this right here. Actually, let's just write it out. I know I say I'm not a fan of writing the 1, but there's a reason why I put the 1 out there, because we'll see that right now. 12 can be broken down to 6 and 2. I'm going to stop with the 2 there because I'm not going to do 2 and positive 1. 6 can be broken down to 3 and 2. Okay. So we're going to stop there. Now I would rewrite my square root of negative 24 with those numbers that I circled here. So like negative 1 times 2 times 2 again times 2. So I have 3 and then 3. Now keep in mind, because it's a square root, you can only pull out pairs. So this negative 1 becomes the I on the outside. Oh, that's like an eyesore, huh? Sorry. I have a pair of 2's right here, so I'm going to take out a 2. Then I don't have any more pairs. I don't have another 2 or another 3 to get out a pair. So then this is 2. Keep in mind, they're all being multiplied. 2 times 3. This is 2i square root. 2 times 3 is 6. So same as I simplified. Again, if you're not comfortable with the perfect squares and you can't break it up, the first method I did, which is kind of written in black, is that I'm making sure I use a perfect square root, which happens to be that 4. I know 24 is divisible by 4, and then I just write out the 6. Now, again, if you're not comfortable with that, you can use a tree diagram, but you're only allowed to bring out pairs. Keep in mind that list of numbers are all multiplying, so you just don't write 2 and 3 next to each other. It's not going to be 20, because sometimes in other cases, it might just be left as 23. Please be careful with that. It's 2 times 3, which is just 6, and it's simplified to the same thing there. And then just to double check our answer, if we got here, they also got 2 plus or minus I square root 6. So a little bit more steps, but again, very similar to what we've been doing for applying the quadratic formula. Taking a look at 26. So it's the same equation, but now we're going to solve it a different way by completing the square. How do we apply completing the square for this one? So in this case here, you want to make sure, we already know how to set it equal to 0, so that's what I'm going to start with. And I'll go ahead and do it right here. Let me just do this. So I'm going to use we've already seen that previous step, set it equal to 0 and have it in standard form. So that's what I'm going to do as well. This is x squared plus, or actually it's minus 4x, right? Minus 4x plus 10 is equal to 0. Now, completing the square works a little bit differently. Here, even though we like it equal to 0, we're not going to make sure we have it equal to 0. What we're going to do is, if you think about it, your A, B, and C, we're going to move the C to the other side. A and B, or ax squared plus bx, is only going to stay on one side. The C moves over. So our C is 10, as we identified before. So plus 10, I'm going to move it to the other side by doing the opposite, minus 10. And now I'm going to have x squared minus 4x. I'm going to leave a little space there because I'm going to do something. That cancels to 0. 0 minus 10 is negative 10. Why did I leave a little space there? Because I'm going to add a number. This is kind of like me jumping already into the square root. Now, remember, whatever you do to one side of the equation, you got to do to the other side. So that's why I wrote a plus underline, because that tells me, all right, I need to make sure I remember to put a number there. What is that missing number that we're going to put? That's going to be based off of your B. Your B is negative 4. So we're going to take our negative 4, and you take your B, you divide it by 2, and you square it. So this is coming from the equation B over 2 parentheses squared equal to. So negative 4 divided by 2 is negative 2. We square that, that is equal to positive 4. So I'm going to place my 4 here. Now we're going to simplify this information. So after finding that missing number, we're going to simplify. This is how we simplify. X squared minus 4x plus 4 becomes x minus 2. Where did I come up with this minus 2? So we already plugged in this 4. Do you see how we got a negative 2 before that? So inside the parentheses before you square, it's going to be negative 2. Or you're going to take that number there. Equal to negative 10 plus 4 is negative 6. Now, yes, we're completing the square. And we have, but we haven't solved it yet. So again, you want to isolate this x. X is inside the square of those parentheses. So to cancel out this square, you have to take the square root to both sides. By taking the square root, you have x minus 2, right? Because the square root and square cancel, equal to, I can't take the square root of 6. It's not a perfect square, but I can take out the negative 1 for I. This is I square root 6, but remember this is positive and negative I square root 6. I'm going to get rid of that minus 2 by doing the opposite, by adding 2 to both sides. And this is going to give me x equals 2. I'm going to keep the 2 in the front. Plus or minus I square root 6. Which again is very similar to the answer that we got, or very similar, is exactly the same answer as we got on slide 25 when we solved this equation using quadratic formula. I know completing the square is probably the least favorite out of all the students I worked with. I know they tend to lean more on quadratic formula. Keep in mind, you can solve it using any of these methods. But in some cases, like the practice and mastery test, you might be asked to like solve a specific way and then stop at a certain step. So it's, although we can use a quadratic formula, we might be forced to use another method to go ahead and solve. But you can go ahead and solve using any method you feel comfortable with. But keep in mind, factoring might not always work. Or something in some cases, only the quadratic formula would be nicer to work with. So let's take a look at this one on slide 27, which is the lesson activity. So question 1 says, solve the two equations in the table by factoring. Then enter the factors into this. Then enter those factors and the solutions in the table. So what we're gonna go ahead and do is I'm gonna go ahead and take on the first one, and then you'll go ahead and follow the same steps as I did for the first one to do the second one. So this is one method that we learned, which is the sum of squares, where pretty much we have two terms and a plus sign in between. So it's going to follow under this one, a squared plus b squared equals, and then you should already have that formula. Go ahead and make sure you fill it in. So if we take our first one here, x squared plus 10, I need to identify my a and b to plug it into that formula. Again, you should have that written in your notes. So I take the first set and I'm like, okay, I know that a squared is equal to x squared. I know that b squared is equal to 10. Again, look how they line up. Now, because they're squares, we're going to take the square root. I want to just have a, so I'm going to take the square root of both sides. These cancels. This is a equal to x. Here for b, again, I want just b, so I'm going to take the square root of both sides. Now, I can't take the square root of 10, so that's just going to be the square root of 10. So now knowing my information for A and B, I'm going to go ahead and type out my factors using the setup that we have up here. So I know I didn't fill it in, that you should go ahead and be able to fill it in, but you're going to go ahead and type it right here. Actually, we'll type it using the equation editor because we have that square root button. So using the equation editor button, you have two sets of parentheses. Remember, the first part is A, which is considered my X, plus bi, or the square root of 10I, and then it's x minus square root of 10I. So that is my factored form for this right here. So now that we found our factor, they want us to find the solution. So I'm going to write out the work in order to find my solution. So now that I know I have the factors here, which I'm going to end up writing up here. So this is x plus the square root of 10I, x minus the square root of 10I. Again, all these steps you're following along, you're going to go ahead and do the same exact thing for the next part, which is the 4x squared plus 25. So by using both of those factors, you're going to separate them because remember, they were already originally set equal to 0. So my mistake here, and I'm going to try to edit. So if you ever close out your equation editor and you need to get back into it, make sure it's highlighted, the equation that you typed in. Hold on. Okay. Hold on. Can we? No. Okay, that didn't work. See, this is the, oops, can I? All right. So I have it highlighted. What I'm going to do is click on the yellow button again, and I should get my answer. I forgot one important thing. This is set equal to 0. So this is the same thing as x squared plus 10. We just swapped it out, but it is equal to 0. So that's my little mistake that I did right there. So now that we know it is equal to 0, or because it was equal to 0, we're going to separate each factor. So I'm going to take the first one, which is x plus the square root of 10I is equal to 0. Then I'm going to take my second factor and have x minus square root 10I equal to 0. And then we're just going to isolate x. So we're just moving that 10I over. So right here at plus 10I, I'm going to do the opposite of it, minus the square root of 10I, minus the square root of 10I. That leaves me x equals negative square root 10I. Again, we repeat the same steps here, but this one's different. Right now we have minus 10 square root 10I. We're going to do the opposite, plus square root 10I, plus square root 10I. And here we have x equals positive square root 10I. Don't need the plus sign there. So what I'm going to do is I'm going to also use my equation editor because again, we have to write out the square root of 10. So I'm going to click under here, click on my yellow button, and type out those answers. So x equals, do I have the plus or minus symbol here? I don't see, oh, I do have it. So I can put plus or minus square root of 10 and have my I. Again, make sure that the I is not inside the square root. That makes a big difference. And we are all done there. So, or actually, we're not done. You're going to go ahead and take on question. You're going to go ahead and do the second part of that table. Again, following the same steps as I did there. Moving on to question 2. For this one right here, you solve each equation by using the square root property. So what I'm going to do is actually I'm going to solve for one of them. I'm going to choose one of the last two, but you're going to follow the same steps. So I'm going to go ahead and take on the last one. So we have 2x squared plus 15 equal to negative 13. Now, the idea is because you only have x or x squared here, you're going to try to isolate this as much as you can. So the first thing I want to do, I don't want to get rid of the 2 just yet, right? Because it's attached to the x squared. Let's get rid of the 15 first. So the opposite of plus 15 is minus 15. So I'm going to subtract 15 on both sides. Then we are going to have 2x squared. This cancels equal to negative 28, right? Negative 13 minus 15. Then again, I want x squared alone, so I'm going to get rid of the 2. Keep in mind, there's no plus or minus in between them. They are multiplying. So the opposite of multiplying is dividing. So we're going to divide on 2 on both sides. This is going to give us x squared equals negative 14. Again, I just want x. So the first goal is to get x squared alone. Now you're just going to get x. So that your next step is to take the square root of both sides. The square root and square cancel. We're left with x equals, equals plus or minus. Now, square root of 14 is not a perfect square. Again, you can double check using the scientific calculator. You'll have a decimal. So we're going to leave the square of the 14 there. But this negative can come out as an I, and you have the square root of 14. But force of habit with complex numbers and imaginary, the I is always written at the end. So you'll have x plus or minus the square root of 14. Again, make sure your I is not written inside the square root. It is actually outside. So then this answer belongs to the last one. Again, you'll follow the same steps for those 3 right there. You're trying to get x squared alone. Once you have x squared alone, you'll be taking the square root of both sides. Again, don't forget, if you do have the I should be written out on the outside. Moving on to question, actually give me a moment here to take a look. That one's trying to see if there's already a typo there. No, there is no typo. Okay, yeah, go ahead and continue with that one. Question number 3. So remember, make sure you're pausing the videos because I'm only covering one part. You should go ahead and cover the other questions. Again, it's very similar to the steps that I followed. This one right here, it says use the quadratic formula to complete the table. To verify your solutions, graph these equations. So again, we're going to go ahead and work on one of these together. We'll go ahead and do the first one. It says the value of the discriminant solution values. So they don't want, we learned about the discriminant, remember, which is the b squared minus 4ac. So this right here, again, the first thing we need to double check on our equations, is it equal to 0? Yes, it is. We're working on the first one together. And is it in standard form? And yes, it is. So we need to identify A, B, and C. So for the first one, my A is 3. My B is positive 4. My C is also positive 4. So I'm going to plug it in because they want the value of the discriminant. So remember, this goes as b squared minus 4 times my A times my C. So we're going to go ahead and enter the B value. So B is 4. Minus 4A is 3. C is also 4. So now we go ahead and solve, which is 4 squared is 16. And then negative 4 times 3 is negative 12. Negative 12 times 4 is negative 48. So then if we go ahead and subtract that, 16 minus 48 is negative 32. So my value of the discriminant that I'm entering here is negative 32. So remember, what condition told us how many solutions would I have here? Because it's a negative under your discriminant notes, right? If it is a negative number, you're going to have no real solution, but 2 complex solutions. So that's what we're going to go ahead and do right now. Now it's asking for the second part, says solution values. So we're going to go ahead and apply this to our quadratic formula, right? So because it does say use a quadratic formula. So if we remember, this is going to be x equals negative. We have our b value, plus or minus the square root of, now remember how this piece is inside the square root? Because we already know the value of our discriminant, we kind of already did a step for ourselves that we don't need to write it all out, because we would be writing this, but we already simplified that. It's negative 32. So that's why I'm going to save myself a little bit of time and just enter negative 32. So remember, all that represents the same thing, all over 2, and then we have our A. So I only need to plug in B here, which is 4, and my A, which is 3. So now we can continue solving. So it's very similar to as what we would normally do, and you would still get the same thing as negative 32. It's just that we already took that extra step. Why we're adding more to it. So from here, we have negative times 4 to be negative 4, plus or minus the square root of negative 32 over 2 times 3, which is 6. Now, the negative 32, I can split, again, to perfect square roots. Or if, again, you're not too comfortable with it, you can break it down by the tree, just take out the pairs. Now, I know the square root of negative 32 can be broken down to the square root of negative 16, which is a perfect square root, times the 2. So if I put this here, I'm going to have negative 4 plus or minus. Now, square root of negative 16 is 4i, and we have the square root of 2, and we're going to have this over 6, but we're going to split it. So again, negative square root of 32 became the negative square root of 16 times the square root of negative 2. That becomes 4i and then square root of 2. Simplifying this by dividing top and bottom by 2, this becomes a 2, this becomes a 3, this becomes a 3, and this becomes a 2. So if I write out my final answer, I don't want to split them. Actually, do they? I was thinking more of like putting the plus or minus symbols in there. Yeah, let's just write it as 1. Okay, so they do have the same, it is going to be set up as a fraction. So I'm going to have, they're both over 3, and I have negative 2 plus or minus 2 square root 2i. Again, you want it, because you have it in a fraction form, you're going to select where you want to enter it. You're going to click on your yellow button, and we're going to type it in. Now, because I have a very large fraction, the first thing I want to do is bring out my fraction button. Then type out the top, negative 2. Don't forget that there you have a plus or minus symbol right there. Then it is 2 square root of 2. There's my I. Bring it down here for 3, and you hit OK. And there's our solution there. Again, you're going to apply those same steps for the second one for question number 3. Moving on to question number 4, we're going to go ahead and do this one together. And it's solving the equation by completing the square. So the first thing I take a look at is that it's equal to 0 and it's in standard form for me. Like it, love it. We want to move our C to the other side. So our constant value here is 6. I'm going to do the opposite of plus 6 and minus 6 on both sides. So then we have x squared minus 4x. I'm going to leave a little space, right? Because remember, I'm going to put a number here. Equal to 0 minus 6 is negative 6 plus whatever number I put there. Now, to find that missing number, what I'm going to do is I'm going to take my b value, right? We say b, we divide it by 2, and then we square it. So right here, my b is negative 4. So negative 4 divided by 2, and we square it, we get negative 2 squared equal to 4. So I'm going to plug in 4 and 4. And then we simplify. So here's that 4 that I got. Then this becomes, so the left side becomes x minus 2 squared. So we kind of go backwards on those values there. And keep in mind, it's what two values or what two numbers multiply to get positive 4, but add to get negative 4. So negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So that b value. So it's also kind of like going back to the giant x idea. This is equal to negative 6 plus 4 is negative 2. Now, again, you want to isolate x because you're trying to solve for it. X is inside the square root with the square. So you're going to do the opposite by taking the square root of both sides. Now we're left with x minus 2 equals, now the 2 you can't take, it's not a perfect square, so you're going to leave the 2 in there. But the negative, right, because you have plus or minus, the negative becomes the I. So a negative, remember, because that's like negative 1. X is still not alone. You have to move this 2 to add 2 to both sides. And this is how we will write it. X equals, right? This cancels. This is positive 2 plus or minus. For some, I'm like forced to want to put the I in the front, but I goes in the back, and that's your final answer. And then again, don't forget to use the equation editor to type that in. You'll have x equals 2. Don't forget there is a plus or minus symbol button for you. There's your square root, 2, and then I at the end. So then that's it for this lesson activity. Again, don't forget to do your self-evaluation. And we've reached the end of this tutorial. Don't forget to double check on the summary. They provided you a little video there. But you did cover quite a little bit of different things. But the idea is now that we have this idea that instead of saying no solution, we have 2 complex solutions. And that's the end of this one.